A very good morning, students. Welcome back to Programming for Problem Solving course. In our previous session, we have discussed about the computer hardware thing, and after that, we also discussed computer software. Then we have seen the relationship between uh, user, computer hardware, software. Then after that, we have seen the computer languages. In our most recent session, we discussed about computer languages. Okay, so this is how we are proceeding in our syllabus, and many students they're asking about the notes. So inshallah, once we complete the first unit, I will give the full notes of the first unit. It is already there on my blog, so definitely when I share the link of these videos, this today's session, along with that, along with that session, I will also share my blog link, so you can visit my blog, and over there you can see not only the material, the notes related to the course, but also the previous year university question papers, some important questions, solved question papers, solved model papers, many different things we have over there. So you can refer those things for your preparation. Okay, so quickly we'll go with today's session concept, that is the creating and running programs. So as we promised in my last session, that we see how the high level language codes can be written in a computer, and how those codes can be evaluated, that is nothing but executed, and how those codes can be processed to check the output. So that is nothing but creating and running programs. Okay, uh, as we discussed many times, your computer hardware will understand only the instructions if they are written in machine language, if they are coded in machine language. So computer hardware will understand programs or instructions only if they are written in machine language. So programs written in high level language, that is nothing but in some other language like C or Java or Pascal, Fortran, all these are different types of high level languages. Examples for high level languages: if you're writing a program in high level language, that program needs to be translated or needs to be converted into machine level language with the help of special program known as a compiler. So what is a compiler? We discussed in our previous session, and with the help of compiler only, we are converting our high level language instructions into machine level language instructions. Okay, the process of compiling and executing a C program is having different steps. It is not a single step process, or it is not a one shot process from where you can directly convert the high level language instructions into machine level language instructions. So it is a step by step process. It is a multi step process, we can say. Okay, these steps are repeated many times, and even if you have multiple steps, it doesn't mean that you will go from start to end in one single shot. Based on the problems in your code written, or based on the errors you have in your program, you will repeat these steps number of times. Okay, uh, so these steps are repeated many times during the development of a program, or during the development to correct errors and make improvements in the program. So whenever it is possible, whenever you have issues, whenever you have errors in your program, so ultimately what we will do, we will correct those errors, and again we'll start, again we process the program with the help of these steps. So whatever steps we proceed, whatever steps we discuss under this creating and running programs, we are going to repeat these steps plenty of times. That is nothing but number of times. Remember this one. So here, this diagram, it depicts, it gives the idea of how the programmer writes the program, and how that program will be given to the compiler, and after the compiler what will happen. And again we have a special type of program called linker, and after the linker what you will get, and again what is the role of runner, and what things you will get after this runner. So over here where we are writing our actual program, the programmer is writing the actual program. This is the source program. So whatever program the user the programmer is writing, we call that program as source program, and that source program we are giving as an input. You can see this arrow mark as an input to the compiler, and the compiler is converting that source program into object code. This is source code and this is object code. That object code is in turn given to the linker, and that linker is taking the help of library modules. Okay, by adding that library modules, this linker is converting that object code into executable code. So this executable code, when you give to the runner, you will get the result, or you will get the output. This result is nothing but your output. So whenever we write a computer program, our intention is to get the output from that program. Okay. So these steps only we are going to discuss one by one. So it is the programmer's job to write and edit the program. Who will write and who will edit the program? The programmer will do that. Okay, the programmer will do that. So basically, in this process, there are 4 different steps. Step 1, step 2, step 3, step 4. And these steps, they will get repeated number of times according to the errors in your program, as per the errors, as per the issues in your program. If you are writing the program in the first attempt correctly, then these steps will be performed sequentially. First the first step, then the second step, then third step, then fourth step, without any repetition. If there are no errors. But if there are issues, if there are errors, then what will happen? These steps will get repeated more than one times. Okay. So what is the first step? Writing and editing the program. Here we are doing that one. The step 2, compiling the program. With the help of compiler, we'll do that. Then third step, linking the program with required library modules. With the help of linker, we will do that. Then finally, the fourth step, executing the program. With the help of runner, we do that. Okay, writing and editing with the help of text editor, compiling with the help of compiler, linking with required library modules with the help of linker, and finally the executing with the help of runner we will do. So if you put these 4 steps in this figure, so this is the first step, this is the second step, this is the third step, and finally this is your fourth step. Like this you can remember. So quickly, the first step, writing and editing program. So generally, to write and to edit the program, we make use of text editors. So I don't think I have to give special information about these text editors. Okay, we have a lot of text editors in our computer. Your notepad, if you are aware of notepad, you can use notepad also to write the computer programs, or you can use any other text editor which are having more sophisticated tools. Generally, what a text editor will have means, the text editor will help to enter, change, store characters into the program. A text editor is a general purpose application. It is not application specific software. It is a general purpose application which can be used to write letters. I mean, not only writing programs, you can do a lot of other things with the help of text editor. Those other things are nothing but writing letters, okay, creating reports, or writing programs as well. So as we said, it is a general purpose application. Text editor is a general purpose application. You can perform a lot of things like writing letters, creating reports, and also writing programs. A more specific, I mean, if you are focusing, I mean, if you don't want to do these general purpose tasks, if you want your text editor to be specific to the programs, okay, specific for writing programs, in such a text editor, you will have some sophisticated features which are helpful in writing programs only. Okay, so they will come up with more built-in features, like they will come up with a built-in compiler, they will come up with a built-in library modules, they will come up with a built-in runner, they will come up with a built-in loader. Likewise, all the tools which are required in creating and running programs, they will come inside the sophisticated text editors. We are talking about specific text editors. We are not talking about general purpose. General purpose means you can use that text editor for many other purposes as well. But if you talk about a specific text editor, then all these tools will also come inside that one. Hopefully you understood. After writing the program, the file will be saved onto the disk. So we have to give a specific name according to your programming language. Okay, the file extension will be according to your programming language. If your programming language is C, then you have to give the file extension as .c. If your programming language is C++, then you have to give the file extension as .cpp. If your programming language is Java, then you have to give the file extension as .java. Likewise, so based on the type of language what we are using in our programming, we will save our program, I mean we will save our file onto the disk with proper file extension. Okay, this will be known as the source file or source code. Okay, whatever file we have written and whatever file we have stored on the hard drive, we call that file as source file or source code file. Okay, and this source code file will be the input to our next step, that is the compiler. Okay, so the second step of our creating and running programs is the compiler step, or compiling the program. The source file is written, which is stored onto the disk. It must be translated into machine language, because the source file is having all high level language instructions, high level language statements. Okay, so those high level language instructions, they must be translated into machine language before giving it to the computer, or before giving it to the CPU, central processing unit of your computer, for processing it or to see the output. Okay, so the source file, it has to be translated into machine language before giving it to the computer. Okay, so this is actually the job of your compiler. Who will do this conversion process, who will do this translation process, means your compiler. Many times we discussed in our previous session, also have given the idea of this one. So your compiler will compiles the source code into machine language code. Okay, the C compiler will have two separate programs. Don't think that compiler means it is a hardware component or something. Compiler is a software program only. It is a software only. Compiler is nothing but it is a computer program only. Okay, this in turn is having two separate programs. Your compiler, it can be divided into two separate programs. The first one is the preprocessor unit, and the second one is the translator. First one is preprocessor unit, and the second one is the translator. So yeah, the first one, the preprocessor, what it will do means, it reads the code line by line and it prepares the code for the translator. So because immediately after the preprocessor we have the translator, so the job of preprocessor is to read the entire source code line by line, and it has to make it ready for the translator. So in the program it will scan, I mean whatever program you have written, in that program we are going to have some special commands known as preprocessor commands. Okay, those, what are these preprocessor commands, very soon we are going to discuss, and very soon you will come to know. When we do the stuff practically, when we write the programs and when we execute the programs, at that point you will understand what are these preprocessor commands. Okay, so the preprocessor, what it will do, it will scan the entire program and it will look for these preprocessor commands. Okay, these preprocessor commands are these special type of commands, tell the preprocessor to look for special code libraries, make substitutions in the code. I mean by reading these preprocessor commands, generally these preprocessor commands tells the preprocessor to include some special files, special header files into our program. So the preprocessor, what it will do, it will replaces the preprocessor commands with suitable library files. Okay, the result of this preprocessor is the translation unit. So whatever output we are getting from the preprocessor, we call it as a translation unit. So what this translation unit actually has means, the code, the program code what you have written, and the substituted files with the help of preprocessor commands. So your preprocessor, I mean your translation unit will have the both things. Okay, so next is the translator. The translator actually converts the high level language code into machine language. So this is the translator's job, is to convert the high level language instructions into machine language instructions. It reads the translation unit prepared by the preprocessor. I mean prior to this step, whatever job we have done, that complete job will be taken as an input to this translator. So the preprocessor, whatever it has done, it has prepared the translation unit, isn't it? That translation unit prepared by the preprocessor line by line, and write the result object module. So what it will do, it reads the translator, it reads the preprocessor unit's output, the preprocessor output, that is nothing but the translation unit. So the translator reads the translation unit line by line, and it will prepare the object module. So the output of the translator unit is the object module. Remember this one. First, the output of text editor is the source code. That source code we have given to the compiler. So compiler, inside compiler we have two different things, the preprocessor and the translator. Preprocessor will take the source code, adds the library modules, and prepares the translation unit. That translation unit we are giving as an input to the translator. The output of this translator is object module. Object module is in machine language. Remember this one. Complete object module. Whenever we say object module, it will be in machine language. And this code will be written in a separate file. Your source code will be untouched. It will remain as it is. Okay. So the object code, it will be written in a separate file. The object module is then combined with other pre-compiled units, hardware related information, to form the final module in machine language. So this object module then combined with hardware related information. Hardware related information is, in the sense, it is different from machine to machine. Okay, machine hardware related information. So that machine hardware related information we are adding with the object module to form the final module. So this final module will get as an output from the translator. Remember this one. Here, even as the final module, even if it is in machine language, it is still not ready for execution. Okay, it is still not ready for execution. It has to go through two more steps, because after compiler we have linker and we have the runner. So at runner only we will get the output. Still two more modules, two more steps we have pending. Remember this one. Okay. So what the translator will do, basically the overall overview of these statements is, the translator will take the translation unit and it will convert the translation unit into object module, and to that object module it will add the hardware related information to form the final module, and this final module we are giving as an input to the linker. Okay, the next step is the linking the program. A C program is made up of many functions, okay, many predefined functions. Okay, so inside a C program, yeah, what are functions, what are user defined functions, what are predefined functions, everything you will come to know very soon. Okay, when we discuss the concept of functions, at that point you will understand. So a C program, it is made up of many functions. Some of them are uh, written by the programmer. We call them as user defined functions. Okay, and they are the part of program. But some functions, okay, known as predefined functions. We not only have user defined functions but also have predefined functions, such as input output functions, mathematical library functions. All these functions are predefined functions. The code will the code for these predefined functions, it will exist inside the library files. Okay, and must be attached to the program before the execution. Even though it is existing inside the library modules, library files, it must be attached with our program before we give that program to the execution, before we give that program for execution. So this is exactly the job of your linker program. Okay, linker, what it will do, it will add the code for predefined functions. It will add the code for predefined functions inside your computer program. Okay, so the linker assembles all of these functions, both predefined and user defined, into the final executable program. So now we got the executable program. After the linker, we got the executable program. So now the fourth and last step, that is executing the program. Once the program has been linked, it is ready for execution. To execute a program, the program has to be loaded into the primary memory. So once the executable program is loaded into the primary memory, it will automatically take the control of the processor and it will start executing itself. Okay, so who will load this executable module into the primary memory? In the sense, the run command of operating system. Okay, the run command, RUN, the run command of operating system will load the executable module into the executable file into the primary memory. And getting the program into the primary memory or main memory is the function of an operating system program known as loader. And where exactly we have this run command? In the sense, inside a special program called loader. Okay, the responsibility of the loader is to load the program from the secondary storage to the main memory and attaching this run command with that executable program. Okay, it locates the executable program in the secondary memory and loads it into the main memory. And after loading, it attaches the run command with this what we call executable program. After loading everything into the memory, main memory, the program takes the control and starts the execution. Okay, so generally all these steps, maybe we are discussing like 4 steps over here. So as I said, whenever we are going for a special type of program or special type of text editor for writing the program, we call that special type of text editors as IDEs. IDE is nothing but integrated development environment. Integrated development environment. And these IDEs, they will have all the tools. That means they will have your normal text editors, they will have your compilers, they will have your linkers, your runners, everything they will have as an integrated modules. Into this environment, you are going to have all these things as integrated modules. So simply you have to open this IDE and you have to write your computer program over there, and you have to press some shortcut keys so that you will get the output. Okay, will not do step by step all these things, even though we studied these things as step by step, but when it comes to the real time application development, will not go in this way. Step by step we will not go. We'll use the sophisticated tools known as integrated development environments, IDEs. And inside these IDEs, we are going to have all these tools, integrated tools. Okay, so simply what we will do, we will open this IDEs and we'll write our program over there and we'll press some shortcut keys before getting the output. Hopefully you understood. And the IDE what we use in this particular course is Dev C++. Dev C++. You can download this Dev CPP from the internet. I have a video created on this one. I will upload this video. So you can follow that video and you can download this Dev CPP from the internet and you can configure it into your computers for practicing the C programs. Hopefully you understood this one. So this is something, the way how we write the high level programs into our computers, how we compile, how we link, how we run, and how we check the output. Hopefully you understood. So the next concept in our first unit is the computing environment. So computing environment is the way how we use the computer hardware. Because see, whenever we are going for computer, why we go for a computer? Because it will ease our day-to-day work. It is very much easy to get a job of 100 people with the help of a computer, isn't it? And even if 100 people will do the job for you, there is a possibility of inaccuracy in that job. But when it comes to the computer, it will not only do the job of 100 people, but also you can expect the accuracy over. With 100% accuracy level, you can get that job done by the computer. So that is the what we call importance of a computer in our day-to-day life. And don't expect that it will do any physical effortful work for us. Of course, nowadays with the help of robotics and with the help of artificial intelligence and other things, it is not only doing the computational job, but also it is doing the physical effortful jobs also for us, isn't it? But as we discuss more of programming, we will not go for physical effort works, we will go for mental effort works only. Okay, the the jobs which do not require any kind of physical effort, rather than they require the mental effort, the mental strength. So when it comes to mental strength, there is more possibility that the calculations may go weird if they will be done by the human beings. But when it comes to the computer, if it will perform that computational job for you, it will perform it with high level of accuracy. Okay, with high level of accuracy, you need to understand and you need to remember this one. The accuracy is very, very important when we are talking about the computer. Okay, so in the early days of how these evolution has been happened. Okay, in the early days of computers, what are the computing environments, how the user used to interact with the computer, what type of hardware devices he used to use, all these things we will study over here in this concept called computing environments. So in the early days of computing, the only environment available was the mainframe computing environment. We call such an computing environment as mainframe computing environment, where the mainframe computer is used to satisfy all operations given to it. There was only one computer and you have to give all your tasks, and at that time it is not a general purpose computer, it is a completely research oriented computer. The mainframe computer, it is completely a research oriented computer and it will perform very limited functionalities for us. Don't expect that you can play a movie on that computer or you can listen to a music in that computer. It is, at that time it was completely a different type of computing environment, very limited type of resources it was using, and a very limited kind of functionalities you can expect from that computer. Okay, so all operations, whatever operations you want to perform, you have to give to that mainframe computer only one single computer. Okay, no sharing of resources from one computer to other computer, nothing over there. Okay, you have to give your work to that single computer and that computer will perform that work for you and give the result for you. Hopefully you understood. Okay, later with the advancement, with the development in the mini computers and personal in the computer world, different computing environments came into existence. Okay, so the first one is, one such computing environment is the personal computing environment. Then we have the time sharing computing environment, client server computing environment, and then the distributed computing environment. Okay, we have first one personal, time sharing, client server, and the last one is distributed. So before this we were having only one, that is mainframe. So we know the situation in mainframe computer. This is your mainframe computer. See how big is the size, and this mainframe computer, it will perform only limited jobs. It will not perform even nowadays your smartphone can perform more jobs than this computer, more functionalities than this computer. And to check the output, they have to depend on these type of tapes. You can see it will perform the calculations and it will print the result on this paper kind of thing. And how these people are checking, even if one single part is going to malfunction in this one, your entire computer will go down. Okay, and the heat these computers will generate, it was very enormous, and you cannot run these computers 24/7. If you are keeping this computer in in shutdown state for around 24 hours or 1 day 2 day, then you can run this computer only for 15 to 20 minutes. Likewise, there are many such limitations and no sharing of resources at all in such big computers. Okay, they are the very initial computers, we can say. So after the development, we got many things like mini computers, personal computers. With those things, we got many different computing environments like personal computing, time sharing, client server, distributed. Likewise, we got. So we discuss one by one all these four. The first type of computing environment is the personal computing environment, and how these evolution has been happened means, in the year 1971, okay, the scientist name you remember, Marshall E. Hoff, he was working for Intel. Okay, has what he has done means he combined all the necessity components of a computer onto a single chip. and they call that single chip as a microprocessor. So the invention of microprocessor has been done in the year 1971, exactly 1 year before the invention of your C language. Because in the year 1972, the Dennis Ritchie at Bell Laboratories, he invented the C language. But before that, in the year 1971, Martian E. Hoff, okay, he was working for Intel, and he combined all the necessity components, all the elements of the central processing unit onto a single chip, and he called that chip as a microprocessor. This was the first computer on a single chip named Intel 4004. Okay, this was the first computer on a single chip. The name is Intel 4004. In personal computing environment, a personal computer, we call it as a PC. PC, you might have heard this term. Okay, will be used where all the computer hardware components are connected together inside a single computer. So when we are saying a personal computer, we'll have our own keyboard, our own mouse, our own display, our own printer, everything we are going to have of our own. The computer what you are using at your home, the laptop what you are using at your home, it is the best example for personal computer, PC. Okay, this environment will have whole computer of its own. The user can perform whatever operation he want. Okay, it is same like mainframe computer, but there the operations were limited, but over here the operations were, you can perform whatever tasks you want to perform, and the size also, the size is also very small, because all of the computer components, all of the uh, uh, computer hardware, it is now integrated on a single chip. So the size of the personal computer, it is very small. So this is a typical personal computer. Here we have the monitor, here we have the DVD-ROM, CPU, CD-ROM, hard drive, keyboard, mouse, everything we are having inside this computer. So without even having any kind of resource sharing from other computers, you can run this computer and you can get the work done by this computer. So this is your personal computer. So then we have the time sharing computing environment. So here somewhat uh, different type of environment we can say. In time sharing environment, many users are connected to one or more mini computers or central mainframe. So here we use terminals in order to connect with the central computer or main computer. Okay, these terminals are non-programmable computers. I mean, when we say terminals, they are not going to have any internal CPU. They will have only RAM, and they will have only the display unit and other input output devices, but it will not have any internal CPU. So all the CPU work will be done by the central computer. Okay, I will show you that over here. See here, the central computer will have the CPU, and all these devices, they are dummy devices. They don't have any CPU. They have other components, like they have RAM and they have all input output devices, as you can see over here, but they don't have the CPU. They don't have any storage capability also, and they don't have any printing capability. So for that purposes, I mean, if they want to perform any kind of task, they have to depend on the central computer. If they want to store anything, they have to store on the central storage. And if they want to print something, they have to depend on the shared printers likewise. So all these terminals, they are the dumb devices. They are connected with the central computer. And over here, whatever job these terminals are having, okay, to accomplish those tasks, to accomplish those jobs, your central computer, the only computer, is responsible. Okay, as the number of jobs are going to increase from these computers, the burden on the central computer will increase, and the delay will also increase, the response time will also increase, because here these computers, they are giving more and more jobs to the central computer, and these jobs will be queued. What will happen? These jobs will be queued at the central computer, and before they get, I mean, before these terminals would get the response from this central computer, the delay period, the response time will also increase. As more and more terminals will increase connected to the central computer, the delay, the response time will also increase. Okay, so that is the problem in time sharing environment. Okay, so this is about time sharing, and there is another type of another type of computing environment, that is a client server computing environment. Here the only thing which changes with the time sharing environment is, here the mini computers or the computers which are connected to the central computer, they are also have the computing capabilities over here. Okay, the computing capabilities, the connected terminal. Now we don't call these connected terminals, we rather call them as personal computers only, PCs only, and they are going to have hard drive, they are going to have CPU, they are going to have internal storage, everything they are also going to have. Not only that, but also the central server will also have such capabilities, shared printers and central storage. If they want to do their job by their own, they can do, or if they want to distribute the work between central server and the PC, they can do in that way. So that is the only difference between the time sharing environment and the client server environment. Over here the response time is faster when compared with the time sharing environment, because over there no distribution of work, only the central computer will perform the entire task. But over here, as your work will be distributed between the PC and the central computer, the response time is more. Okay, so the last type of computing environment, that is distributed computing environment, here the internet is the best example. So here we have more number of servers involved and more number of clients involved. Okay, so here suppose let us assume this as your Google server and this as your Yahoo server or Amazon server. So suppose if you want some sort of task to be accomplished by Google server, then you can visit Google server, and if you have some sort of task to be accomplished by Amazon server, you can go to the Amazon server. Likewise, here the work will be shared between multiple servers and multiple clients. Here when we say distributed computing environment, the response time is very much effective when compared with other type of computing environments. Hopefully you understood this concept, the computing environments, the remaining stuff and other things related to these uh, computing environments we will discuss in our next class. The students, the attendance when I'm seeing of my last videos, it is not up to the mark. So this weekend, I mean this, I'm going to finalize the attendance of this whole week, and I'm going to post the attendance in the beginning of next week. Okay, so make sure uh, you have to post the attendance, and before posting the attendance you have to watch the videos completely and you have to attempt the questionnaire whatever I'm asking, because without the questionnaire, as I said, I'm not going to consider the attendance. Many people, they are simply keeping hyphens in the answer text box and they are submitting the form and they are thinking that they will get the attendance. You will not get the attendance. I'm simply removing such records from my attendance calculation. If you are only posting the attendance in the comment box or in the chat box or using Google form, you are only keeping your roll number, your name, and the rest of the answers you are keeping something of your wish, and you are expecting that you will get the attendance. No way. And for your information, the questions, the assignment questions what I'm asking in every attendance form, they are of very much easy. Even if you watch the video, uh, you can easily answer that one. Okay, no need to refer any material, no need to refer any internet something. If you watch my video only once, it's more than enough to attempt that questionnaire. Okay, very simple questions I'm asking, so try to answer that questions, try to get the attendance of every class, because it is of important. And this time, this semester, many times we warned you people that 75% attendance is very much required in order to write the internals, without which nowhere we are going to allow you to write the internals. And afterwards don't come to me that because of this reason I might have not attended your lectures, I have not posted the attendance. Likewise, hopefully you understood the importance of the lectures, online lectures. Thank you very much, students.